Next slide. All right, the demo. Would you switch over, Jim?
Thanks, Jason. Let me first bring up a live video image, everybody, and to prove it is live. That's Jim White's hand right there. I come to you live from the CTO office and user computing, which is who I am with at Dell. And what you're seeing here in the video image right now are quite a few sensors, all connected to, I should say sensors and devices connected to our Dell Edge Gateway 5000. In fact, that 5000 product is the black box sitting in the center of your screen here. In addition, I have a Pat-Light signal tower, which speaks SNMP, or at least that's how we're using it in our little demo here. I've got some BLE devices. I've got a little Texas Instrument BLE Lite, a Bosch XDK sensor pack, which is bristling with all sorts of different types of sensors, temperature, humidity, accelerometer, things of that nature, and also a Texas Instrument sensor pack, which has similar type of capability there with a whole load of sensors in it. Lastly, to the left, I have a Fisher Technic little conveyor belt punch system, which will simulate some of the industrial equipment that we think Fuse could be used with and help drive that equipment and or provide sensors around it to stop that equipment if something were to be in the way or cause maybe harm to somebody. So a variety of sensors all connected up to our gateway, and that gateway is running Fuse. The more than a dozen microservices are running on that gateway right now, and all working together here, hopefully, to cooperate and produce the demo that you're about to see. Oh, one last thing I should mention to you, you will notice here, this is Jim's cell phone. We are also using MQTT to chat or communicate and get data off of other devices. In this case, my cell phone is producing all sorts of information like its location, temperature, battery statistics, things of that nature, reporting into Fuse as well. So lots of different protocols, lots of different sensors. And let me bring up now our Fuse user interface, what we call our local management console. The local management console is a little UI we built on top of Fuse. Fuse is ordinarily going to run headless, but for demonstration purposes like this, we found it very advantageous to have a little user interface that you can be able to see things, see the data coming in, see how we trigger commands back down to devices, much better than looking at something like JSON or XML data the entire time. What we see in this dashboard is right now the 6 sensors that are, or devices that are currently connected up to Fuse in that gateway. Again, the Fisher Technic, the BLE lights, my Android phone, all sorts of things connected up here. Importantly, Fuse is about collecting data from a multitude of sensors, speaking all different types of protocols using their own formats. Fuse's job is to bring all that data in through what we call a collection of device service microservices. Each device service speaks a particular protocol, brings that data in, transforms it into a common format, feeds that into the rest of Fuse that can use and actuate on it. When we say actuation, what we mean is its second important job is not only take that data, but look at that data and be able to actuate back down and command and control devices. So to begin that discussion or demonstration, let's take a look at that Fisher Technic punch machine and conveyor belt. I can go to this particular UI and you'll see a number of options or states for the various pieces of equipment on this little toy industrial type setting environment. And in this particular case, I'm going to go ahead and set the belt in motion here, and I'm gonna have to switch quickly after I've applied it here so we can see that live on the screen. And there you go, live demo of my conveyor belt in operation as I just triggered that through Fuse. So that's the actuation of equipment or devices through the use of Fuse. Again, we're about collecting data as well. So I can go to Fuse and pull up any particular device. One of my favorites is the sensor packs because they're just bristling with all sorts of different types of capability out there. And let's go take a look at, for example, what is the actual temperature in our lab right now. Nice thing about these kinds of demos with these little sensor packs is I can take, for example, a little sensor pack and throw it around a room where we're in a large setting, and actually you would see in live real time or near real time the accelerometer and gyroscopes in there just bouncing all over the place in these kinds of graphs. But you can see here, it's a little balmy in our lab here. We've got lots of equipment around, and Jim's breathing all sorts of hot air, so we're about 81 degrees Fahrenheit right now. But you get a sense, again, that we're able to collect data from a multitude of sensors, in this case BLE, and command and control other devices. In the case of the Fisher Technic equipment, that was communicating via serial connection out to a little controller for that industrial simulation environment. Now, collecting data and being able to actuate is great, but if we have to do that entirely manually, that's not going to get us anywhere in this edge environment as well. What we also have to do is be able to rely on what we call local edge analytics in Fuse to be able to actuate things based on the readings that are being made off of all these sensors. And to demonstrate that, I'm going to go back to my video here, and I have the two sensor packs again on the table here. I've got the Texas Instruments sensor. It's got a lux meter in it, and I've got the Bosch sensor in it. And again, it has the accelerometer in it. And I've actually triggered or set up a rule in our Fuse system, in our rules engine, to actuate things like the PAT light and our BLE light when these particular devices are either changing in axis in the case of the XDK, or on the Texas Instruments, when light is detected on the bottom side of that little sensor tag, it lights up the BLE device. So we're actually seeing data coming up through these devices into Fuse, and then Fuse turning around and actuating other devices with its local edge analytics in order to be able to command and control additional devices. So we're seeing multiple protocols, multiple data formats, all coming in, being ingested by and being used by Fuse. Now, I should mention, in our particular case, the Fuse rules engine is a rules-based rules engine. For those of you in the open source community and familiar with Java products, it is a Java-based rules engine. It's a bit heavyweight, admittedly, but it is open source, and we want to kind of be able to provide what we call a reference implementation for that particular microservice. And that's the point. In the future, we expect there are going to be lots of other partners who are going to provide lots of different edge analytics that may replace or augment that rules engine. And that's the beauty of Fuse. Any particular piece, any microservice is completely replaceable by another in a different language. As long as it speaks the same API, it can communicate with and participate in the ingestion of data, the command and control devices, and other capabilities built into Fuse. Switching back now to my screen, yes, we also have in Fuse all sorts of other what I call ash and trash services. We have an alerts and notification mechanism, so you can be emailed, for example. In this case, I'm set up to be an email recipient if a new client for data off of Fuse makes a subscription request. We have things like logging capability and the ability to see down and ferret out information that might be happening on any one or multiple microservices out there. So the typical things that one would expect in any kind of a system such as this. Again, the nice thing about these are all microservices themselves and can be replaced and or communicated with via the REST API that's built around every one of our microservices. Now let's talk a little bit about, once we've got the data ingested into Fuse, what do we do with that data? If we're at the edge, that data eventually probably has to work its way up through the fog into your enterprise and cloud environments. For that, what we've done is built into Fuse an export capability. For those familiar with the architectures, it is based on what's called a pipe and filter architecture, meaning it's very easy for us to allow you to define exactly what kind of data you want, from which sensors, how you want it, where you want it, and maybe if you need it encrypted or compressed, specify those kinds of features as well. What we're looking at on the screen right now is our little export registrar client that communicates with our export services and allows clients to dictate what it is they want and how they want that data sent to them. I've already set one up, in this case, working with my Fuse instance, to send the data off to a cloud MQTT topic, or if you will, queue that's off in literally the cloud. I'm going to enable that right now. And you can see based on my UI here that it's currently going to export that data in JSON format. So all the data that we just talked about or saw in our demo, coming off of things like the Fisher Technic equipment and the BLE sensors. All that data now is streaming into this Cloud MQTT instance. And there we go. We see the JSON data pouring in now to that topic in the cloud. You say, well, wait a minute, I don't want that in JSON format. That's fine. Let's switch it up. We'll change that out to XML. And if I return now to my cloud instance and zoom all the way down, I see the data now coming in not JSON format, but XML. So we're providing a pretty dynamic capability built in Fuse to getting that data off as well, and being able to connect up in the hierarchy of the fog edge systems up through the various nodes in your environment. Of course, here too, again, microservices. So if you don't like the way we've done it, if you want to change it, if you want to alter it, if you want to provide other capabilities, simply replace those microservices with some of your own capability. Lastly, as part of the demo, I want to chat just a bit about, well, how do we get Fuse deployed to systems? Again, as Jason mentioned, every one of our microservices today is Dockerized. So what you were seeing as part of this demo is, again, about a half dozen or more microservices all running in their own separate containers. That's a lot of containers, and that's a lot of management of software to get on a box. So how do we do that in a little bit more convenient fashion? Well, we started to experiment with options here. And one of the ones that we like is a tool called Docker Compose, kind of an augmentation of the whole Docker environment. Docker Compose allows you to create what essentially is a manifest file of the containers you want. It's nothing more than a markup language document that you provide to a particular server or system, in this case to our gateway. And then with one line command, it pulls in all of the Docker containers from the cloud or your private server, and then gets them all up and running for you. I had a couple of interns working for me this summer, and they worked on this tool, which is nothing more than a graphical user interface that helps produce that Docker Compose manifest. And in fact, you're able to go to this little user interface we've got in Cloud Foundry today, request that you want a particular template, or if you want a particular manifest file for Fuse, in this case, maybe our Fuse Alpha instance, simply download that document, use that document on your own machine, and it will set up Fuse and all of its components to include things like the database and all the networking necessary to make all those microservices talk to each other. And if that's not enough, if you're really customizing things, maybe you're a developer and you're looking at using a certain collection of the microservices, but not all of them, we've provided a mechanism where you can actually pick and choose the microservices you want, and again, create your own custom manifest file, your own custom Docker Compose file, use that to get those services up and running, and then add your own services or replacement services as you go. These aren't perfect solutions, and there's still a lot of work to do, but it does show that we've started efforts to think about how do you orchestrate and get Fuse running in multiple environments.